Now, sir.
Yeah, now is
Okay.
there. Okay, good. Okay, man. So that part, the probability part is clear, right? Everybody.
Yes, sir.
Okay. So now what I'm essentially doing here is I'm taking a range of thresholds now. Okay. I don't want to see. So I don't want to decide that zero point 0.5 will be the optimal threshold to be used. But for my case, which is the correct threshold to be used, I want to decide that. Okay. And for which I am taking in what do you say? I'm generating an num, numpy array of thresholds. Okay, between 0 to 1. Okay, so this linspace function, actually what it does is when you give the start point and end point, when you say how many numbers should be there between 0 and 1, okay, it will basically, it will divide the space between 0 and 1 accordingly, and then it will give you that list of thresholds. Okay, so now for each element of this threshold, okay, for each element of this threshold, I want to run the entire prediction uh, part. Okay, so I'm not directly taking the classification label. Okay, I am taking the prediction probabilities. I'm not just using dot predict, but I'm using prediction probabilities. Okay, and I'm getting this. What is the size of prediction probability? Is it has two columns, okay, and n number of rows. N stands for the number of test examples, and it gives, in each row it gives you the confidence with which it has to classify, it will classify the test example into class 0, and the other value will be the confidence with which it can classify it to class 1. Okay, these two confidences it gives for all the test examples. Okay, and I'm taking the other part, the confidence values with respect to class 1, because that is more important. Detecting the breast cancer is what is more crucial for me at this point of time. Okay, and if you see, this kind of an approach is there in MATLAB also. I must have said earlier also, this thing, this programming construct. Okay, if you see here, what I'm doing here is, so the first value here will be 0. Okay, and the threshold, the first threshold value will be 0. I'm checking which all probabilities are greater than or equal to threshold. Okay, and and then I'm using that as an index inside this class underscore one underscore props. Okay, and now I'm assigning so whichever values, these values, if you see 6.44, 5.19, 2.08, whichever values these are greater than or equal to threshold. Okay, and all those values will be assigned 1. Okay, and whichever values are less than threshold, essentially I am assigning all those values with 0. Okay, so I have set of series of ones and zeros in this, at this point of time. Okay, and when I'm assigning this, essentially if you see here, okay, I have ones and zeros in the form of an integers. Okay, but what happens when I'm assigning simple one, what happens is it takes this class underscore props is something like a float operation. Okay, so I'm converting into an integer first of all, so that I can use the other inbuilt scikit-learn functions. Okay, so now what I'm also doing here is I'm calculating this four variables: true positives, true negatives, false positives, false negatives. I am passing it to the output of this thresholding operation. That is one input that I passed to these four functions. The other input will be the actual test label is what I pass. Okay, so this is the other parameter that I pass. And these, after you pass these two parameters onto these four functions, you will have these true positives, true negatives, false positives, and false negatives. And once you have them, as I said the last time, you can calculate the precision values and the recall values. Okay, so one thing here is I don't know what will be the exact size. If I want to exact size, I have said that, okay, I want to generate 10 different numbers between 0 to 1. Okay, and so to make this dynamic, what I did here is I have what do you say, I did this precision appending and the recall appending. Okay, so one thing here is we have to every so for every threshold value, okay, for a certain threshold value, I have a precision calculated and a recall calculated. Okay, I'm just printing this threshold over here. Okay, and at the end, now this precision, I have given it as a list, I have to convert into an NP array. Okay, so that I can use this px plot function. Okay, so I have 10 different values between 0 to 1, so that I have 10 different corresponding, I have 10 different values of precision and 10 different values of recall. Okay, is this part clear? Any doubts here?
No, sir.
Right, for every threshold we are calculating precision and we are calculating recall. Okay, so these two values we are recording. Okay, in some cases what happens is the denominator will go into zeros. Okay, when the denominator goes to zero, this division operation will give zero, division by zero error. Okay, in order to avoid that, what I did is I have added a negligible value here. Okay, so that that division by zero error won't happen. Okay, so once I have this values, once I have this array of precisions and array of recalls, I'm using this plt matplotlib plt pyplot function and passing it on to this plot. Okay, and x label recall, x y label precision, this you anyways know. Okay, and I'm using plt.show in order to show this precision recall curve. Okay, so now let me run this. Right, so this is the precision recall curve. Okay, see what is the precision that we talked about last time, right? So let's go back and try to understand what is precision, right? So precision is calculated as true positives by false positives plus true positives. What does it mean? True positives plus false positives will give me the total number of examples which are classified as uh, as class 1, that is which is classified into a breast cancer, right? So the image features are coming in, and when now you are classifying that particular test example into a breast cancer category. Okay, so totally how many examples are classified into class 1 is what you will get by false positives plus true positives. And among them, okay, few of them can be, there is always a possibility that few of them can be incorrectly classified into the breast cancer category. Okay, so now what, for which they are, all those incorrect examples come under false positive case. Okay, so when I am doing this true positives by true positives plus false positives, essentially I am getting among the number of examples which are classified as positive examples, what is the proportion of correctly classified positive examples among the total number of examples which are classified as positive. That is the percentage that we are calculating with precision. Okay, so can you tell me now, uh, how should be the precision value in an ideal scenario, whether you need to have it as high or low?
High.
Yeah, we need to have a high precision, right?
Yes.
For an ideal machine learning system, you need to have more number of correctly classified examples, right? Rather than having an incorrectly classified examples. Okay, you don't want these incorrectly classified examples, even though it's not a big danger thing, but you don't want to terrify somebody who doesn't have a breast cancer, and your machine learning model says that that particular person have a breast cancer. Okay, you don't want such kind of scenarios to happen. That means for which you need to have an high precision, and so that is one thing. So let's look at recall now. Recall is true positives by true positives plus false negatives. Okay, false negatives means there are few examples, there are few patient records which actually have a breast cancer, but they are incorrectly classified saying that they doesn't have a breast cancer. Those all things come under false negatives. So true positives plus false negatives gives me total number of, okay, positive examples which are there in my test set actually. Okay, and I have true positives by, so the correctly classified by total number of, among the total number of positive examples, how many of them are correctly classified, what is the proportion of the positive examples which are correctly classified among the total number of positive examples that are there in my test set. Okay, so that proportion you call it as a recall. Okay, so do you want to have a high recall or a low recall for
High.
an ideal system? Yeah, you
High.
need to have a high recall also. You need to have a high precision as well as you need to have a high recall for an ideal machine learning system. Okay, so now what are we doing here? By varying the thresholds, okay, between 0 to 1, okay, I'm getting different values of precisions and different values of recalls correspondingly. Okay, and I'm using this plot function and then plotting it, and this is the curve I got. Okay, so this curve I got after plotting for the different thresholds. Okay, if you see here, okay, this value, whatever this value is coming over here, okay, it's not exactly the high precision and the high recall. Okay, I am not getting for exactly for 0.5. Okay, but I am getting it for a different threshold. Okay,
0.7.
right, so maybe 0.7, it between 0.6 and 0.7. Okay, are you able to see this observation?
Yes, sir.
Yes.
Right. Junita ma'am, is it clear?
Yes, sir. Yes, sir.
Yeah, Vijay sir,
Sir,
is it
that
clear?
means h theta of x 0.7, it is classified as class 1. Greater than 0.7 is classified in the class 1.
No, when you take the threshold as 0.7, okay, then you will have a better accuracies for your data set.
High,
Huh.
high precision and high recall.
High recall, because for 0.7, so no, sorry, so this value actually we need to find out this, this is not threshold, right? Sorry. Okay, we need to
This
see
is not-
for which value of threshold this high precision and high recall is happening. Okay,
Yes.
correspondingly you should choose this, choose that, because this x-axis is recall. I misinterpreted as threshold. It's not threshold, sorry. Okay, so you need to see for which threshold this high precision and high recall is happening. Okay, and you will choose the value of threshold probability accordingly. Okay, and for that value of threshold for your input data set, you will have better accuracy.
Sir, actually, Karthik sir,
Yes, sir.
actually this is linear regression, sir. Obviously,
Logistic regression, sorry.
sorry, logistic, yeah. Obviously, it should be like that only. Precision, when it goes high, recall should recall should also
No,
go.
it need not be the case. No, you are confusing with curve fitting, the linear line fitting. Okay.
Okay.
And the other case. Okay, this is not the curve fitting that I am talking about. Okay, this is the plot between precision and recall. For every threshold, okay, I'll have a certain value of precision and recall. Okay, I'm just calculating it. I'm plotting that curve. That's it. The precision recall curve. This is called as a PR curve. It's popularly referred in the machine learning literature.
Okay, sir.
Any doubts here?
So now what is the threshold here, sir?
Threshold we have to find out, ma'am, for whichever value of precision and recall. Okay, so let me try to print it. All right, so
So we are given for printing in the threshold.
just a second. I think this has to be closed. Print. I'll put it in loop. I'll print threshold. What is the name of this array of threshold? Thresholds. Thresholds of I. Precision of I, comma, recall 5. Say now, see, you see this, ma'am, for 0 threshold, okay, you have a precision of 0.64, okay, and what do you say, the recall of 0.99, okay, and at some point, actually, both of them, you need to have a maximum, right, and you should be able to pick up that point. Maybe for 0.7, I guess. Yeah, 0.7, it's 99 and 0.90. Right. So I think so. The 0.7 will be the optimal threshold.
Sir, even for 0.4, it is 0.95 and 0.99.
Yeah. So I need to see that point one where that dip is happening. I'm able to see it. For which value of threshold that dip is happening in the PR curve, correspondingly, I need to take that. So this dip is happening here, if you see, for a precision of 0.99, right? And a recall of 0.7 approximately.
So does that threshold of 0 indicate that there is no classification, sir?
Which, ma'am?
When we say threshold of 0, means in the logistic curve, we are at the bottommost point, which is overlapping with the x-axis, no, sir? So then there is no classification. Should we take it, sir? Then 0 value is not a valid, should we interpret it like that, sir?
Yes, ma'am. Yeah.
Okay. So then in none of the cases, this value will be valid, correct, no, sir?
None of the cases, yeah, this value will be valid because that's not an idealistic scenario. Just for the sake of experimenting, we have used it.
Okay, sir.
See, whichever point I have this PR curve starting dipping, right? It's going into a dip, right? Though that is a point I have to start consider as the what do you say, ideal point for my selecting the threshold. Shall we calculate the accuracy also? Can somebody help me with accuracy? What should be the numerator and what should be the denominator?
Tn plus Tp is the numerator. Tn plus
Tn
Tp
plus Tp. Yeah.
divided by all thing. Tp plus Tn plus Fp plus Fn.
I'm adding small chota number. This is to avoid 0 by 0 division error. and I'm also calculating the accuracy. And let's display the accuracy also. See, if you have this fundamental T and TP, TFN, right? So if you have those 4 fundamental components of your confusion matrix, you can have all the different possible metrics in the machine learning literature. So that is where the fundamental thing happens. Right? So I have recall, PR curve, see, this is another design constraint. If you see, you have to talk about something called trade-off. Okay, so if you see the accuracies, okay, where I have high precision, it doesn't mean that I will have a high accuracy. Okay, in the same way, where I have high accuracy, I'll not have a high precision, or it need not be the case where I'll have a high precision or high recall. Okay, all these three are independent metrics. Okay, and just because accuracy is used, what do you say, accuracy is widely used, you cannot use it the same metric for all the different kinds of applications. Okay, for something like a medical imaging application where you don't you expect that you will have a high precision and high recall, and you are not bothered about an accuracy at least. Okay, you are, see, accuracy is something which is dealing with how your true example, sorry, the positive examples and negative examples are getting correctly classified. Okay, in a crucial application like medical imaging or credit card fraud transaction detections, okay, these places, actually you cannot have what do you say, these are the places where irrespective of whether you will have an high accuracy or not, you don't want some fraudulent transaction getting classified into as getting classified as a genuine transaction. Okay, and in that case there's a huge loss for the bank. In the same way, a person who has the breast cancer, okay, and you don't want your machine learning model to classify it as an absence of breast cancer. Okay, that means you need to worry more about precision and recall rather than accuracy part for your breast cancer example. So based on your example, you should choose based on the criticality of your application that you are currently considering, you should choose the metrics accordingly. Okay, just don't blindly go with only accuracy. In the same way, for linear regression also, majority of the times we consider either mean square error, mean absolute error. Okay, but those are not the only metrics that are available for you. Okay, so there are several other metrics which are there in the literature, okay, which are more suitable according to that particular application. We'll look into that part also. Currently let's more focus on this classification part. Okay, and this is the point which I wanted to drive you today. Okay, precision, recall, accuracy. Okay, based on your application, you should decide on which will be the correct metric for you. Okay, just because accuracy is used widely, it need not be the same metric or the same metric to be used across any kind of an application. Is this clear?
Yes, sir.
Right?
Yes, sir.
Pratibha ma'am, is this fine?
Yes, sir.
Yeah. Vijay sir, is this fine?
Yes, sir.
Sir, for breast cancer data set, all these precision, accuracy, and recall values are good.
For this data set, it might be good.
All are having percentage 96, 93.
But you need to ensure that you have the highest possible values, ma'am. So you don't want 99% also. You want as 100% preferably, because that 1% error can cost a life of one person there. Correct. You should further work towards how to improve it.
Okay.
Right, because this is a very critical application, right? Just because uh, you have just because there is a limitation in the what do you say, just because there is a you have high accuracies, high numbers showing up here, okay, it doesn't mean that that is a good system. If you have a 99%, what does it mean? It's almost like for every 100 examples, your 99 examples are showing correct, that one example is going bad. You don't want that to happen as well, because that is very crucial. Okay, if that one example is corresponding to a person who has a third degree of a breast cancer, and you are not detecting that by using your machine learning model, and that will be huge cost that you are assigning to your model now, right? It will cost the life of a person there. So you need to ensure that you need to have a best possible values always. Okay, so I would recommend you to finish the earlier assignment, right? So I would all of you, I would request you to go through something called true positive rate and false positive rate and the significance of it. Like the way we have understood about precision and recall, we will be talking more about true positive rate and false positive rate tomorrow. Okay, those are also the important metrics, and if time permits, we will talk about F1 score also. We will talk something called area under the curve. Okay, we will also talk something called ROC curves. Okay, area under the curve is also another important metric in the machine learning scenarios. Okay, we will talk about area under curve as well as receiving operator characteristics, I guess. So receiver operating characteristics. So we'll talk about ROC curves also tomorrow. Good. Is this clear? So I would highly recommend all of you to have a quick reading about true positive rate and false positive rate, and we will talk tomorrow about it.
Karthik sir.
Yes, sir.
Sir, when this CNN, no, C convolutional neural networks and everything. So when we can have that one, sir? I will finish after this one, sir. AUC or UC.
Yeah, because you need to understand the different design constraints, right?
Okay, sir. So probably next week you will start, sir, that one?
May not be immediately next week. It might take another couple of weeks.
Okay, sir.
Because see, these are the different components that you should consider even in CNNs also. Because I have to first introduce what are the different things that you will use in CNNs even before talking about CNNs, right? So that's the reason I'm focusing more on that part.
Okay, sir.
Now, when I introduce all these components, no, what happens is for you, CNN is just another logistic regression. That's it, nothing else. You will easily understand. That's another simple, another model, nothing else. Now you know how to analyze for the same CNN, the way you have done for logistic regression. You will do the same kind of analysis with CNN and decide which is the best model, whether CNN or logistic regression, something like that.
So PyCharm is enough for this one, sir, for the CNN, or
CNNs we will use Colab because that might need a GPU.
oh, Colab, sir. Okay.
We will try to use Colab.
So in that we have to go for TensorFlow and Keras, right now, sir?
Yes, correct.
Okay, sir.
Okay. Chalo, then I'll see you tomorrow. I'll request you to what do you say? If possible, calculate this metrics TPR and FPR for your scenario. Okay. And then let's catch up tomorrow. Okay. Yeah. Have a great evening ahead. Bye.
Sir, shall I stop recording, sir?
Yes, ma'am. You
Okay,
can
sir.
stop recording.
Huh.
What you can do here is you can upload it in YouTube. Okay. And then send me those links. And then later what I'll do is I'll try to combine these two session videos, and then I'll upload in SciTech Talks the YouTube portal. I have to first combine these two things first.
Okay, sir.
Okay. Yeah. Okay, ma'am. Thank you. Thanks for the help.
Thank you, sir. Thank you, sir. No problem, sir.